Hello, it's Mr. Morin again, and today we're going to make a video talking about how do we name binary covalent compounds. Okay, so there's a few words that we need to make sure we understand. Binary and covalent. Binary just means that we have two elements being bonded together, and covalent means that they're going to be sharing electrons. So I made a previous video talking about ionic compounds between ions, where we have a positive and negative ion. Now we're going to look at covalent. So in a covalent compound, the way we identify that it is covalent is that we have two nonmetals that are going to be bonded together. Okay? So the most important thing you can do when you're trying to name a chemical or write a formula from a name is make sure you're identifying what type of bond it is. We have different sets of rules for ionic, covalent, acids, bases. So if you don't use the right set of rules, we're not going to end up in the right place. Now, covalent are actually some of the easiest ones to name. We don't care about charge. Charge, not an issue. Whenever we were looking at ionic compounds, charge was a very big part of it, making sure that everything balances out. We're not going to be thinking about charge at all today. So we're just looking at things in this part of the periodic table, and when they bond together, they're going to be sharing electrons. We're not trying to get anything to balance out. We do need a way to identify how many of each element we're going to be using, and that's where these prefixes come in. We're going to use these prefixes to literally just count and say how many of each atom we have in our binary compound. So we have mono for 1, di for 2, tri for 3, tetra, penta, hexa, hepta, octa, nona, and deca. So make sure you're starting to memorize these. It should go pretty easily as we use them over and over. But these are our prefixes that we're going to use. So the way we're going to name these, we're just going to name both nonmetals using the prefix to identify the number of each present, but we're going to change the ending to "-ide". Just like we did with our ionic compounds, we need some kind of ending to identify that the name of that chemical is done. If we list a bunch of covalent compounds together, the "-ide" almost serves as a period at the end of a sentence. It tells us that's the end of the chemical's name. Okay? So we're going to change the ending to "-ide" of the whole compound, not each atom involved. Also, don't use mono on the first atom. So whenever we're looking at something, we only use mono if we're identifying how many of the second element has just one. Okay, so let's look at an example. If I have carbon dioxide, so all of us should be pretty familiar with this. It's a compound that we've heard of quite a bit. So carbon dioxide, how do I know that's covalent? Well, carbon is a nonmetal, oxygen is a nonmetal, so that tells us it's covalent. The other thing that's a big giveaway, anytime you see one of these prefixes as part of a name, you know that that's going to be a covalent compound. Why that's important is we're not going to pay attention to charge. We're not going to start counting what group they're in and trying to get things to balance out. That's one of the biggest mistakes students seem to make, is trying to use ionic rules for covalent compounds and vice versa. So if you identify that this is covalent, we're literally just going to count and figure out how many of each one. So the prefixes in front tell us. If there's no prefix in the front, well, it's because we don't use mono if it's that first element. So if there's nothing in front, that means there's just one carbon. Dioxide means that we have 2 oxygens. So we would have CO2. Okay, let's look at another example. If I have a formula and I want to write the name, I know this is covalent because carbon and oxygen are both nonmetals. So now I need to just name both of them and use these prefixes. So I have one of each, but I'm not going to use mono on the first one. Okay, so I would call this just carbon monoxide. Now it's possible that for a little while it's going to be tricky to know exactly where do I put the "ide," especially in things like phosphorus and sulfur. We wouldn't call it sulfuride, we'd call it sulfide. We wouldn't call it phosphoride, we'd call it phosphide. So it's a little bit tricky to find that spot in the word where it feels comfortable, but you should pick up on that pretty quickly as we do more of these. Let's do another one going from the formula to the name. So here we have Si2Br6. So we need to make sure we understand, if I look at this on the periodic table, silicon and bromine are both nonmetals, so I'm not going to worry about charge. I'm just going to look at my prefixes. I have 2 silicons, so I would call this di-silicon. And I have 6 bromines, so then I would say hexabromide. Notice that ending tells us that we've ended our compound. So we have disilicon hexabromide. Okay, and the best way to kind of get better at this is just to do more practice. So let's look at some more practice. So if I have a handful of these, if I want to go from the name to the formula, and notice just glancing at these, I can easily tell these are all covalent because all over the place I have di, tri, mono, hexa, tri. So anytime we see these prefixes, it tells us that it's covalent. Also, these are all nonmetals. So going from the name to the formula is pretty easy. We just look at the prefix. I have dinitrogen, which means N2, trioxide, O3. Now I look here at the next one, silicon dioxide. There's no prefix on silicon, so it means I just have 1. And dioxide means I have oxygen with a 2. Here on hexaboron monosilicide, hexa is for 6, so we have 6 of our borons. Monosilicide means we just have 1 silicon. Okay, so that's when we would see that mono, whenever it's the leading prefix on the second element. Dihydrogen monoxide, dihydrogen means I'm going to have 2 hydrogens. Monoxide means just 1 oxygen, and we don't have to put a 1 if there's just 1. And the last one would be sulfur trioxide. Sulfur without a prefix means we just have an S. Trioxide means we have oxygen. And there are 3 of those. Most people do pretty well going from name to formula. Going from formula to name, it's not that much more difficult, but you do need to make sure that you're paying attention, looking at the names of these things, getting it right. So for the first one, we have P4S5. So our prefix for 4, if we need to take a glance, we have all these prefixes over here still. So tetra is for 4, penta is for 5. So we would say tetra phosphorus. So we don't change the ending until we get to the second one. And we have 5 sulfurs, so we say penta sulfide. Problem is some of these names are long and I'm running out of room. So make sure you notice the ending is ide. We have tetra and penta because we have 4 and 5. The next one we have CCl4. I know L's and I's kind of get confusing. but this is a lowercase l. So we have one carbon, so we just say carbon. We don't say mono. And I have 4 chlorines, so I'm going to say tetra chloride. Here we have 2 borons and 1 silicon, so our prefix for 2 is di. So we say diboron. And we have 1 silicon, so we say monosilicide. So we end that I. It's a silicone, it's silicide. CS2, we have 1 carbon. We don't have to say mono, so we're going to say carbon. We have 2 sulfurs, so we would say disulfide. And then our last one, we have chlorine and oxygen, both nonmetals, so we know it's covalent. 2 chlorines would be dichlorine. Notice I don't change the ending until the second one. We have 7 oxygens. Our prefix for 7 is hepta. I would make sure you're starting to memorize these, but we have hepta. Heptaoxide. Hopefully you found this video helpful. Send your teacher an email if you have any questions, and I hope you guys have a good day. Thanks.